Well, welcome everybody, tutorial 7. So we're just having a look at the following. Now I'm going to be brief with limits because the insurance policy idea has said, but when we're looking at a limit, we're suggesting that x approaches, in this particular case 4, which is infinitesimally small, and for all intents and purposes, that means that we're going to invoke a kind of function notation, but they are not the same thing, and this is very important. Okay, so 43 for this one. Alright, for part B, again, the limit of x, that's our insurance policy for a quotient. So in this case here, now we're using a bit of gymnastics this time around, in that we are going to recognise that as x approaches 5, the denominator would become 0, so x cannot equal 0. So that's good because our insurance policy assures us that that'll be the case. It won't actually become 0. But look at this. This is gymnastics. This is the difference of two squares. So the difference of two squares is itself a binomial product in A and B, just with a plus minus. So that's the way I would set that up. So you were just required to recognise, putting the extra part in, 5 squared. And don't forget the limit there. I've just put that equal sign in. I shouldn't have done that. So there you go. All right, so we've got our x squared. Now this becomes a limit as x approaches 5 for a binomial product in x and 5, because that was the gymnastics where we used recognition, over x minus 5, and of course we've got a plus and a minus for convenience. So what that means is that we'll get a cancellation there. So in actual fact, we've got the limit as x approaches infinitesimally small to x plus 5. We can use that function notation idea, but it's not function notation. It's 5 for all intents and purposes 5, which gives us 10. So that's our part there. All right. So hopefully that's taken to you, and it's not something that you need to be overly concerned about. The insurance policy is there because of this idea of infinitesimally small, getting into the comfort zone while not actually taking in the comfort zone. So I'm going to be a little bit cheeky now with this particular example, because x, as we know, can't be. Now, I could be wrong in this, and you just need to be mindful of it, but I'm going to assume that the factors here are, in fact, one of them is x minus 2. So I'm going to cheat completely, is the word. I'm going to put x minus 2 as a factor. Now, what would be my other factor to give me this polynomial up the top here? X squared, tick, x. Now, I've got something minus 2x. I've got minus 2x. So to get to 2x, I would need a 4. I would need a plus 4. Now, does that work for the final term? Minus 2. Yeah. Tick, tick, tick. Wow. So sometimes in maths, it kind of works out that way. So you can go through the whole factorising, completing the square process. Sometimes you can just use a bit of intuition. Okay, so we're not going to actually do the whole function notation thing, because it's not function notation. It's a scientific mathematical science's approximation to 2. That is, it's infinitesimally small, and so we'll end up with 6, the difference. Okay, so we've got this one here. Limit of x approaches 1. And so it's the same idea, even though it's a non-mnemonic, which means we could use our favourite old completing the square, dividing through by 3. But we could be a bit cheeky and say, well, how about if x minus 1 is a factor? That'd be a bit nousy, wouldn't it? That'd be a bit nousy. So we'll do, as x approaches 1, we'll say, well, what's the chances there's an x minus 1 on the top? So now, because it's a non-mnemonic, this is going to be a strange form, because it won't be x, because that would be x squared, wouldn't it? And we know that it's 3x squared. So this first term here I'm counting on it being 3x. So let's see if that fits. X times x is 3x squared. Tick. And then we've got x times something. And then minus 3x. Ooh, minus 3x. We're trying to get to minus 5x. So I reckon that might be minus 2x. So let's do our first one. X times 3x. X 3x squared. Tick. Minus 2x minus 3x is minus 5x. How good is this? Oh, look at this. Minus times a minus is a plus. Yippee! We did it. Okay, so by a bit of nousiness, we were able to show that the limit as x approaches 1 is in fact 3x minus 2. And so using the function notation idea, but not actually being function notation, it's just a mathematical science's approximation to that. So 3 minus 2 will be 1. So a bit unexpected, but ta-da, there you go, it's 1. All right.